here at DataStax. I've been working with Cassandra for about 2.5 years, so I've seen a lot of things go horribly wrong. And the idea of this next half an hour is that I give you enough information so you at least avoid the 16 things that I've seen go horribly wrong over and over again, and not put your application in jeopardy. And I have sounds, and this doesn't work. All right, so we're going to start. First question. Oh, first we need our categories. Our categories are, first, math is hard. The second one is RTFM. If you don't know what that acronym means, it's read the fine manuals. So 20th century and physics. So we're going to start with math is hard for 100. This was very high due to see a histogram showing the majority of reads hitting hundreds of SS tables. Anybody want to raise your hand and take a shot? Okay.
Read latency.
Who agrees? Who thinks it's read latency? Yeah, exactly. Read latency. So, see histograms, if you haven't experienced it yet, it's well worth taking a look. No tool, see histograms is where you find it. It's a lot like reading the Matrix. So, unless you're using a newer version of Cassandra, over 2.1, it's interesting to be able to read. But once you learn how to read it, and if you need any assistance with that, please come find me. I'll be wandering around for the rest of the day, and I'll help you out with that. But one of the first things it shows you is the average number, or how many SS tables are read or have to be opened in order to do a read. You can probably imagine if that's hundreds on average. If you do most of your reads with hundreds of SS tables, that's not going to be enough. That's opening up lots and lots of files. Generally, if you do see hundreds of SS tables being read, you have a few ways of fixing that. Most probably your compactions are falling behind, which is a whole other topic to discuss. But you want to think about doing some compactions or maybe changing your data model a bit, or changing your compaction strategy. All right, so you get to choose the next. Oops. Go ahead and choose. RTFN for 200, okay. Throwing caution to the wind here. The doctor recommend turning this off. I say it isn't a recommendation, it's a requirement. Okay, back there.
What is the swap?
Give this man a piece of swag, that's correct. So this is one of those lovely things that when I read the documentation, I just kind of shake my head. Because they say, they make it a light recommendation. Don't turn on swap. It's not a good idea. It's never a good idea. It's specifically not a good idea with Cassandra. Anyway, go ahead and pick our next topic.
Physics for 100.
Physics for 100. These can only spin so fast without creating miniature sonic boom. So even though Cassandra was designed to minimize disk seek, SSDs are still a better choice for low read latency SLAs.
Spinning hard drives.
That is correct. What is rotational disk? So for those who haven't gone through a data modeling course or have never played with the Cassandra CLI, it's well worth taking some time to understand how Cassandra lays down data on disk. It is designed to read and write sequentially. Writes, it makes total sense. It gets flushed to disk. Those SS tables are immutable. Pretty simple for that. But for reads, how you model your data is essential for how you're actually going to pick the data up off disk. And it was designed to put the head down once on a spinning disk and move it as little as possible. So anytime you're going to be doing lots of random reads, that's an anti-pattern in Cassandra. Still, SSDs are still going to reduce the amount of I/O and therefore reduce your read latency quite a bit. But you still can use rotational disks very, very effectively. All right, next. 400. So 20th century for 400. You should not use this to find out exactly how many rows you have in your Cassandra database. Alright, so you have to pick who's first.
What is count star?
Pretty close. I'll give that to you, but it's select count star. That's right. This is a very common problem that I see over and over again with people who are new to using Cassandra and have a DBA background like I do. So I have to say, my first day on the job at DataStax, I installed this Cassandra thing, I loaded some data, and then I just select count star. And I said, but it takes forever. I thought you said this thing was fast. And then Patrick was my mentor. So then Patrick told me, you can't join tables either. And I was just like, I've nothing to do with this Cassandra thing. But select count star is a very difficult operation to do in a distributed system, and just do not plan on using it to find out exactly how many rows you have. Finding out how many rows you have in a Cassandra table is a whole different topic. We can discuss that later if you want. All right, next one. You get to choose one. Math is hard for 300. Updating 90% of your rows with a TTL equal to 0 to purge data because disk space was running low was this. Do we have an answer? Okay.
A bad idea.
What is a really bad idea? That's right. So this actually came from the customer site. I got an email saying that they were running out of disk space. They're an entertainment company that has a large presence down here in Southern California. And she said because her disks were filling up, that she wanted to get rid of 90% of her data. She didn't really care about which data got purged. So what she decided to do was use TTLs, which is a time to live with Cassandra. So she's updated 90%, random 90% of the data with a TTL equal to 0. Does anybody want to give me tell me what happened in Cassandra there? Okay, go ahead. Yeah, so an update. Yeah, you could continue to run out of disk. So an update in Cassandra is marking the old rows deleted, and it's tombstone. It's not removed from disk until your GC grace expires, which is by default 10 days. And then adding a new row, which then got immediately tombstoned. So instead of having 90%, so she just effectively doubled or tripled? I think tripled the amount of data. Yeah, triple the amount of data. Okay. But she didn't set GC Grace. She didn't change GC Grace either, so she just kept on adding disks to her system before she decided not to. Not a good idea. So that is a very bad idea. So, good answer there. All right, you gotta choose next.
Physics for 200?
Physics for 200. You need to consider this when you look at the speed of replication across remote data centers.
What is bandwidth?
Bandwidth is a good one, and bandwidth has a lot to do with, there's another,
The speed of light.
there we go, there's the answer. Give that man a piece of swag. What is the speed of light? The speed of light is not just a good idea, it's the law. So if you do have, the data can only travel so fast. So putting data centers take actual time, longer than a lot of people's SLAs out there, in order to pull data between, say, Tokyo and San Francisco. All right, go ahead and choose the, your next slot.
Math is hard for 400.
Math is hard for 400. Adding this one word to session.execute in your application code will greatly enhance your application's perceived performance. Do we have any Java developers out there? If you don't know about this, you really should. What?
Yes, CL1.
CL1, that's a good answer, but this is actually just yeah, go ahead. Cache and parallel, close. Just gonna go ahead and say, what is async? Yeah, sorry, a little obvious for those who've used this before, but I have gone to client sites who are talking about first they tell me that the Cassandra performance is really bad. And so I do all my normal, I just assume Cassandra's performance is bad for some reason, and I go through all the performance tuning, and I'm like, no, stress is showing that it's running fast, your data model is good. So we start looking at the application, and there's an amazing amount of people who forget to use the keyword async in order to create asynchronous messages to Cassandra rather than waiting for each one to return. All right, who had the last correct answer? We'll let you choose again. Keeping you busy, Devin, sorry.
You get to choose again. Math is hard for 200.
Math is hard for 200. With replication factor equal to 2, and the consistency level was quorum, each quorum actually, many operations were failing when a single node was down because of this simple math equation. Yeah, 50%, so it's pretty close. So what is the calculation, or what is the formula for figuring out quorum? Anybody know? Replication factor divided by 2 plus 1. So if your replication factor is 2, so 2 divided by 2 is 1 plus 1 equals 2. So the story here goes that I was on my way up to Seattle to see a client to just kind of say hi, check in, and they told the night before, they sent me an email saying, we have 2 data centers and all of our reads are timing out. Most of our operations are timing out, we're not too sure why. So I get to the client site, we start talking about it, and they tell me, yes, the replication factor is 2, their reads and writes are set to each quorum, and they have 2 data centers. So I did actually put up on the board the 2 divided by 2 plus 1 equals 2, and kind of helped them figure out that what they were basically saying is their consistency level was equivalent of all, right? They needed all replicants to respond. So if one of their nodes is down in one of the data centers, not really a good idea to use Cassandra if you're using it for high availability. All right, so next.
RTFM 400.
RTFM 400. See, we're staying away from that category. That's very interesting about all of you. If you set up a data center in San Francisco and another one in Tokyo, and use a simple snitch strategy, this will surely happen. You've already gotten your, go ahead.
What is no data will be replicated?
Well, it won't be replicated because, I think that's close enough, because everything will time out. So the simple snitch strategy is basically saying that what you said was a data center in Tokyo and a data center in San Francisco, you're actually saying that's one data center. So it's going to be waiting a long time, again, because of the speed of light, which we discussed earlier. So these are the average latencies from AWS East, AWS West in milliseconds. And again, you have to keep these things in mind when you're looking at your own SLAs. Because this is definitely, all of these latencies are higher than most of my clients' SLAs, as far as rated rights are concerned. So one little mistake when you set up your snitch by using simple snitch can cause your entire cluster to not be responding the way you think it's going to be. All right, great. What's the next category? RTFM for 100. 2 gigabytes is too small, and 20 gigabytes is probably too large for this, but people have been known to use both in production and had horrible things happen. Oh my God. Deb is in charge of this, so.
What is exabytes heap size?
What is our heap size? That's right. Now there's a lot of debate here, and I was actually thinking about changing this particular slide because there's a Jira 8150, if you haven't looked at it before, that does actually recommend slightly higher heap settings than we had before. For the most part, for the last 2 years, we've been recommending for Cassandra about an 8 gig heap. And that's because the amount of garbage that's collected in Cassandra. If you do any type of GC profiling, you will see that we do tend to create a lot of garbage, especially on reads. So if you have a read-heavy workload, taking a look at your JVM settings is essential, and I would highly recommend spending a day or two profiling with your GC and making some modifications and taking a look at Jira 8150 on some recommendations on things to change. But for the most part, you don't want to start with the heap, and you also don't want to make it too big, or you will have too many GC clauses. 8 gigs is a good place to start, probably walking it up to 12 or 16, but I wouldn't go any over 16 or 20. Okay, you're gonna run back. Or if you want to yell what your next category is.
RTFM for 300.
RTFM for 300. Woo! It's a daily double, which we don't get anything interesting from the daily double, sorry about that. So these should be used for atomicity, not for performance.
What are lightweight transactions?
Lightweight transactions, that's not actually what I was looking for, but that's a very good answer. Yep.
What is batch?
Batches, that's right. Mostly, and the reason why is that because lightweight transactions people typically use them correctly. Batches people use incorrectly over and over and over again. And that's a lot from our relational background. Batches were there for performance in all of our traditional relational database systems, but they're not used for performance in Cassandra. On the contrary, you will get an overhead, especially if you use a log batch. So don't use batches if you're looking for performance gains. You use batches if you're looking for more of an atomic type workload. All right, go ahead and choose. So 20th century for 300. The docs recommend setting this to 100 megs times the number of cores. You can yell if you want, if you have a voice, you can yell.
The new heap size?
The heap, what size?
The new size?
New size, yes. Yes, we definitely want to, we discussed a little earlier about garbage collection and JVM settings. Parnu, or your new size, is very, very important, and you'll see this a lot in your reads, but your write performance will also be affected quite a bit. So make sure that you've changed your Parnu to be 100 times, at least starting at 100 times the number of cores. Again, if you adjust down, you adjust around that, that's a pretty good place to start. All right, while you're back there, you're going to choose the next one.
Physics 300?
In a CF stats output, locked flush riders are a good indicator of this. I think we have a hand over here. Has everybody used CF stats before? There's lots of heads going up. Yes, Rachel, we use CF stats all the time. It's always
I use Kyle.
what?
Hide this item.
That's right. What is an I/O bottleneck? That's right. So if you suspect that your disks might be not fantastic, or you're trying to convince somebody that you need to spend some money on some better quality disk, or you're just trying to figure out, why performance is slowed down quite a bit. Block flush writers in your CF stats outputs. That should be an automatic. As soon as you see blocked there, the first thing you should be doing is going to your I/O subsystem and doing some I/O checks. All right, next.
Everything's fine then?
No.
You want to
You have to play by the rules a little bit. A commonly used relational database management object that should only be used on low cardinality columns and not as a band-aid for a poorly designed data model. What is that called? You're really running it down, sorry. Going back.
What is a where in select?
It's an object. Looking for an object.
What is a secondary index?
Yay, give this man a mug. That's correct. I was a data warehouse DBA architect for on and off 15 years before I started Cassandra, and so I spent a lot of time managing indexes and figuring out which indexes to put on my tables. It goes with the old mindset of how you data model in a relational database. You data model from the data versus you data model from the queries. And then you create indexes for your queries. A lot of those habits fall over into Cassandra. And we see people using secondary indexes as a band-aid. Like they're saying, well, I probably modeled my data incorrectly. So we create a secondary index. What's it you need to keep in mind is the secondary index is a new table within Cassandra. So you are already duplicating the data, so you might as well create your own table to handle the type of query that you're trying to do with your secondary index. Yes, you do need to maintain it yourself. Yes, that is on the roadmap to not have to do that sometime this year, so you're only going to be paying for it for a little bit. But secondary indexes are good for very low cardinality type of objects. So things like gender, or basically here's the rule. If your cardinality of your secondary index is greater than the number of nodes you have, don't use a secondary index. That's a general rule. If you need to know why, you can find me afterwards. So we're going to do our last one, so 20th century for 100. This storage mechanism introduces a single point of failure and totally negates the performance benefits that Cassandra gains from reading and writing sequentially. No, because there's some RAID systems that are okay. I won't hurt you if you do RAID 1 or RAID 0. That's stupid, but I won't hurt you. I'll hurt you if you do this. Yeah, I think Devin's going all the way back. Yeah.
A NAS or a SAN?
That's right. Please, I beg you, don't use a SAN with Cassandra. If your storage has an Ethernet port, it's the wrong choice. We have clients that are very large providers of SAN, and what they do is they put an individual SAN on each node. Now, unless you're made of money or you build SANs for a living, that is not totally practical. So, and then I hear it all the time. I go to clients and we've got some guy come up there and says, but my SAN can provide the same I/O or better I/O than your disk, and that's not the point. Do not use a SAN, please. I do have Italian roots. I will find you. All right. And our last and final Jeopardy question is, the best way to keep up to date in all the new research and Cassandra anti-patterns and use cases? What? What is Planet Cassandra? That's right. I had to throw in my mailing list, IRC channel, planetcassandra.org. Get involved. That is the best best way to stay abreast of everything that is going on in the Cassandra world. As we learn new things, we like to post it up. Just last night, all of the evangelists were sitting around, and we were talking about new things to build. So if you want a new presentation, you want new content, just let us know. Keep us informed. And I think we're done, and it's time to go talk about use cases next. So thank you very much. Thank you for playing Jeopardy.